Okay, so I'll get started. And if you come to my talk tomorrow, I'll say the same things as I'm talking about right now. So who am I? I'm Thiago Macieira. I work for Intel. As you can see from this picture, this is not my kid, this is me. People here in the front can see this is from 1982. I've been involved with high technology since I was a kid, apparently. My trajectory has been that I started getting into open source the same time as I started getting into Qt. What brought me into the world of open source was that I tried to do IPv6 networking, and I was thinking, well, where am I going to contribute this? I decided to contribute it to KDE. That was back in 2000, and that led me to work for Trolltech, which then led me to work for Nokia. And since 2011, so just over 3 years from now, right now, I've been working for Intel at the Open Source Technology Center. Right now I live in Portland, Oregon, which means I arrived yesterday morning at 7:30 on the red eye. I'm still okay right now. I'm not sure whether I'm going to be okay during the social event. I might be crashing. Hopefully I'll be able to talk to you guys. I'll be able to answer questions. For those of you who don't know me, I'm also your friendly Qt core maintainer. I've been doing maintaining a lot of those things, trying to get new improvements out of it. Both this session and the one tomorrow are based on improvements we've done on Qt over the past couple of years. The one tomorrow especially is really new stuff we've worked on at the end of last year, I think, with some colleagues at Intel, as well as with people in the Qt project, especially Olivier here in the front. So if you've got questions, ask Olivier, don't ask me. What else can I tell you about me? Living right now in Portland, Oregon, where it is slightly warmer than here, but started to rain. So we have that problem with the Pacific Northwest. We say that it doesn't rain that often. It only rains about once a month. The problem is that the rain lasts 30 days. But yeah, so why am I here? I wrote this blog which was then the Qt Labs a couple of years ago. It was titled String Theory. And I was just talking about encodings and strings and things like that. And it occurred to me that we never actually presented some of the stuff we've done for Qt 5. And we're already 2 years down the road from when Qt 5 was released. So I wanted to talk a little about it. And let's start with how many Qt classes doing string we have. Anybody? No, tell me the class names, not the count. QString, QLatin1 string, QByteArray, what else? QStringRef, QStringLiteral, which is not a class. I heard somebody saying that. Anything else? C++ standard classes also exist. I think I added here QVectorCar. Somebody might want to do that. In the past, of course, we had QCstring, Q3C-string. I don't know how many of you guys were still from that era. And yes, we have the standard library classes. And of course, we can still have the character literals. So there's a lot of that. And the question I wrote in the abstract, I don't know if you guys read it, was which one do I use and when? First of all, let me tell you, do not use QVectorCar for strings. It works, and by construction, it's exactly identical as a byte array. There's actually one difference. QByteArray has the null terminator. QVector doesn't. But outside of that, they're actually identical memory layout, because we just try to reuse code as much as possible. So I see lots of people here standing up by the wall. So if I can just ask people who have a seat next to you, just shift so people get a seat. People here in the front, yeah, I don't think people want to sit in the front, so you can stay where you are. Thanks, everybody. Okay, looks like most people got seats now. Thank you. So I divided this talk in 3 parts. First, I'm going to give you a little overview of what I'm talking about. What's a character type? What's a codec and things like that. And then I'll talk about how to use them in Qt, what they exactly do and how to use them. I thought of showing some of the improvements we did in the code. I don't think I'll have time for that, and it's also a bit too technical. So let's get started with what is a character set, or char set for short. It's a mapping of characters to bit representations, basically. This is a very old chart, as you can see. It probably was typed or drawn with a typewriter. This is not from computer era. This is how ASCII, US ASCII actually got defined. It maps characters, so letters, numbers, some punctuation, some other interesting symbols, some control information to bit representations. This is apparently in decimal instead of hexadecimal here, but they're the same. The interesting thing is this one occupies 7 bits. So whenever I'm going to talk about US ASCII, there's a lot of confusion when people talk about ASCII. Sometimes they mean a 7-bit version, sometimes they mean 8-bit with extensions, and then it gets complicated. Let's be clear, whenever we talk about US ASCII, and whenever you read the Qt documentation, US ASCII, we mean the 7-bit version. For legacy reasons, the functions called from ASCII and to ASCII don't mean that. They were actually a misnomer. We invented them Qt3. We're saying, well, everybody writes their source code in ASCII, so let's just call the function from ASCII and ASCII. And people started using them, and in Qt5 we decided to change and say everybody actually writes their source code in UTF-8. And that's what happened. So if you read US ASCII, we mean this. If you the 2 functions in the QString class, please never mind them, try not to use them. The code chart also has a few symbols there, some control information. I'm not going to get into that. The interesting thing is that in olden days, there were a few character sets that were incompatible with ASCII. So for example, in Scandinavia, because they have 3 more letters in the alphabet, what they did is that they decided to replace 3 extra symbols in the ASCII char set with the extra letters. And since IRC was invented in Finland, and IRC is case insensitive, we conclude that a bracket is the same thing as a curly brace. And most IRC servers still think that. And if you have your nickname or a channel name with one of the 2, they just map to each other. They're the same. It's an interesting trivia. But there were a couple more that were completely incompatible. So of course the 6-bit encodings, which nobody uses anymore, and the IBM EBC DIC. I actually should have looked up what it means. They're legacy. They're not compatible with ASCII. UTF-1, which probably got a lot of people with question marks in their faces now. What is UTF-1? Why should I know? I haven't ever heard about it. UTF-1 was a Unicode transform from mid-90s, before UTF-8, and it was ASCII compatible. It was just that the high bits were completely different. It was actually much more difficult to work with. which was when actually they wanted to have the entire Unicode to be non-mapping, not overlapping with ASCII as well. So let's not get into that. What we want to talk about is the ones that are, whoops, wrong button, compatible with ASCII. They are the modern encodings. Most of those are supported by Qt, supported by operating systems and things like that. And whenever I say modern encoding, I mean that they actually are compatible with ASCII. So if I write ASCII text and try to decode with any of those, the text remains the same. There's no transformation of the low 127 characters. Any change that these guys make requires at least 1 byte that has the high bit set. So it's easy to detect when you do have ASCII, and you can keep your text, if you're writing source code, in just plain English with no extra characters with these. I divided them in 3 categories here. Fixed width, that means that it's always the same number of bytes per character. Usually 1, right? Usually 1, but of course the Unicode transformations also have 2 and 4 bytes. We have variable width, which means that you cannot tell just by reading how big they are. You have to find the escape sequence and figure out where they go. And the interesting ones are the stateful ones. So the stateful ones, that actually mean that when you have a specific start byte, then all of the rest has a different state than from before. We try to avoid those because some characters in ASCII might have different meaning. Some bytes might have different meaning depending on whether they were preceded by an escape code or not. Let me just say that you can ask questions during the session. I don't mind. We do have a lot of people here, so I can't accept questions from everybody. But if you have questions, you can just raise your hand. I'll repeat the question afterwards. So let's talk about Unicode. What is Unicode? Unicode is a consortium of companies who are trying to get to standardize basically everything about text. So they publish, of course, the character maps, and I've got an example here. Just took a random page from our character map from a chart from Unicode, copied a little of it. It defines what each character by code point means, a symbol, a representation of it, its name, and anything that might be related. But more than that, it actually produces technical reports. So it tells us how to transform, how to do line breaking, what is a word, how do I do word separations. When, sorry, when we have text, complex text with, for example, right to left rendering, it tells us where to do the right to left, how to handle it, how to do cursor movements. So it's a lot of information. Unicode, and all of this is free. You can just download it from unicode.org. They actually go even further than that. They actually produce the Common Language Data Repository, so the CLDR. And that contains a lot of information, not just about the characters themselves and the properties of, is this a number, is this a punctuation symbol, things like that. But they contain, for example, all of the locale information. What is the currency for a particular locale? How do I format numbers? How do I format dates? How do I format times? What the time zones are? All of historical information about time zones. So all of this is actually produced and collected in Unicode. There's also an overlapping standard by ISO, the 10646, which defines the full width of the character mapping. So by agreement, they're one and the same, they're identical. So the character mapping, when I look at, for example, 27F1 in ISO 10646 and Unicode, they mean the same character. The only difference is that technically, the 10646 could have many more. They could use the entire 32-bit space, but they decided to limit themselves to the same number as Unicode. And just to talk about what is a codec, since I talked about what a character set is. Codec is simply the contraction of the word encoder and decoder. Just like modem, for those of you who didn't know, modem is a modulator, demodulator. It just means that we take a character from a given encoding and recode it to something else. Let's put it this way, actually. The encoder means I'm taking text of a known variety, and my own interpretation of text, and I'm encoding the text in a given character map, so bit representation of it. If I were writing text and just trying to type it, that would be a type of encoding. Now, when I'm trying to translate from one to the other, when I'm trying to think of characters in usually I'm thinking of Unicode. I'm thinking of UTF-32 or UCS4. So translations from one type to another, for example, to convert from ASCII to something completely different, usually go through these. So I'm giving a lot of information. One more that is important for you is what your editors usually support. So if you're using Qt Creator, it's usually doing UTF-8. So it's going to save the file as UTF-8. UTF-8 is an encoding by Unicode and by the ISO and IEC and IETF, everybody together. It encodes Unicode without loss. Your typical Unix editor, if you're not using Creator, is usually going to encode using your locale, which usually on modern Unix systems is UTF-8. So it's usually the same, you're not going to get a problem. You can just write any text, and it's going to be read by anybody else the same way. Except if you send to somebody using Visual Studio. So this is the first of many failings I'm going to show you about Visual Studio. That they encode with the locale, the Windows locale, which is almost never UTF-8. There's a way to change it to UTF-8. You just install the Vietnamese language pack on Windows and switch to Vietnamese. I think there's another way, I'm not sure exactly. I never managed to get it to work. I tried a lot, I was trying to do tests for this presentation. It just never worked for me. Apparently there is a way to change the Windows character set. I never managed. If somebody finds out, somebody knows any better than I do, just send me an email. I would love to find this out. So what happens with Visual Studio if I try to type something outside of the locale? So imagine I write on my text both Greek and Russian, which obviously will never fit any of the code pages. Well, it is going to save as UTF-8, but it's going to insert the byte order mark at the beginning of the file, which the Unix editors don't like. So if you try to open a header file, so an interesting thing is that by the way that the processors interpret, the compiler interprets the source code, is that it opens the file, finds the include, inserts the whole text of the file at the include point. So if your CPP file has a byte order mark, the compiler usually is fine. If your header has a byte order mark, it stays in the middle of the file. Then it's no longer a byte order mark because it's the middle of the file. So the compiler says, why the hell do you have this here? So it's kind of okay if you write CPP files in Greek and Russian, but not headers. Anyway, so just a little about codecs in Qt. Obviously, we have built-in the Unicode ones. We have a couple more. We have codecs for Japanese, Korean, and Chinese, the big five, GP 18030. we have a bit of Thai, we have the Shift J, so we have a couple of others. Most of the time in the modern Qt builds in Qt 5, they're disabled because we just fall back to ICU. ICU, a library that we use, and if you're here and you've tried to deploy a Qt application with Qt 5, you go like, why do I have to deploy this 18 megabyte library? How many of you have had that question? Yes? And the reason is that ICU includes all of that Unicode information I talked before about. So they include all of the CLDR, all of the Unicode properties, they're all inside. That's why it's 18 megabytes in size. Sometimes people ask, how can I depopulate that library? Because I don't ship my software in Japan. I don't ship my software to somebody, writing ancient Egyptian. So why do I have to have all the information? It's actually difficult to depopulate ICU. It's not impossible. There are ways to do this. It's sometimes that you don't expect what's going to happen. So take my case. I'm Brazilian. I live in the United States. And I also speak French. And a bit of Norwegian too. So what happens is that my locale in my system is a mix of all of those. Its UI is written in Portuguese, because that's what I prefer, but I also have currency in dollars. So all of the locale information is a mix. And you don't know when you're trying to make your application whether when you give it, okay, you don't ship it in Japan, but maybe there's a Japanese user who configured their system for Japanese. And then all of a sudden your application might not have all of the information. We try to get some of that information from the system. It usually comes with most of this. Modern Unix systems also have ICU built in, so we don't have to ship the 18 megabytes, except that the ICU guys don't maintain binary compatibility, so it's a challenge for us. And every single contributor summit, there's a question, what are we going to do about ICU? Questions so far? Okay, let's get into code now. What are the C++ character types? Basically, there are 4 character types, and car divides in 2 here because there are 2 ways of doing literals. Car is 1 byte. Does anybody find it strange that it's 1 byte? Why? Do you think it's strange that it's 1 byte? Doesn't have to be. Are there any machines where character is not 1 byte? Here's an interesting thing for you guys. The definition of byte is the car in C. Because the C standard says that the width, the size of car is 1 by definition. So it is always 1, which in turn means that the number of bits that exist in the C car type is the number of bits on that bytes machine. That's why byte doesn't always mean 8 bits. Just a bit of trivia for you guys. So the definition, if anybody asks you how big a byte is, you have to look up what is a car on that machine. Usually today, in modern machines, they are 8 bits. There were machines that were different. 6, 7-bit, even 9-bit bytes existed. Of course, we have the wide character. And how wide is a wchar? The answer is as big as the platform wants it. And it can be 1 byte. So the C++ standard does not tell you how wide it is. For us in Qt, for us doing work in Qt, there are 2 possibilities, either 2 or 4. Windows does 2 bytes, so 16 bits. Everybody else ends up doing 32 bits. So whenever you're writing a literal like this with the capital L in front of it, you don't really know the size. This is why C++ 11 came up with these 2 more. So they are fixed. If the machine supports 16-bit types, then car 16 is 16-bit. And if they support 32-bit types, it's a 32-bit for car32T. Again, for us working on Qt, that is the case. These are 16 and 32-bit in type. The biggest difference is whenever I write this, right? So if I write, the literal, if I write my text, how does it get encoded? Which bytes will show up in my memory? Up until C++11, as you can see, we don't know. Could have been anything. And it's actually a little worse with the car. C++11 at least guarantees us that the output is going to be properly encoded. So we think, yay, finally I can write text like this. That's actually what prompted me to write the blog a couple of years ago. C++11 wasn't out yet. And I thought, let me look into this and see if finally we can have source code written like this. I can write Russian, I can write Greek, I can write Japanese in the same source code, and everybody will agree that what it means. Often, that's a bad idea. Because I told you that even if I put the U here, if I put the U there, I know that the output is going to be properly encoded in one of the UTF transformations. The problem is that I did not control the input, because my file is a collection of bytes, right? How do I know that the compiler interpreted this the same way? And that's something that the Unicode, the C++ standard committee did not fix, and they're reluctant to fix. Why, you may ask? How can it be so difficult? It's just a bunch of files. And everybody uses UTF-8 these days. Why can't the C++ committee say that it is something? Well, has anybody here, besides Olivier, I guess, read the C++ standard where it says how bytes get interpreted into C++ code? Raise of hands, who has looked into this part of the C++ standard? That's what I thought. So for everybody who is listening to this talk later, nobody raised their hands. Here's why. It's because it's a mess. There are 5, not just 1. There are 5 character sets that a compiler must know. It has the source character set, which is how do I read those bytes and interpret them as C++ source code. The C++ standard defines that the basic source character set must support, of course, all the letters, all the digits, every single one of the punctuation symbols that we use in C++, like the period, the colon, parentheses, brackets, curly braces, and things like that, and nothing else. So it's technically valid for a compiler not to understand what an @ symbol means. We don't use it in C++. Of course, it gets extended. It means there's more characters available in those byte representations. And then it interprets those, it loads into memory, and has to understand them as the translation character set. That's what it loads them into, which has to be a subset of the universal. And then when it's writing it out, it has the execution character set, the one for bytes, and the wide character set for wchar. So it could be something like this, like I drew here, the top picture. Things are disjoint. There are characters that exist in narrow form that don't exist in wide, and things that might exist outside that you cannot write. Usually, modern days, they're simpler. The source execution character set is the same as the execution. So it just does a binary translation 1 to 1, and the wide character set is the universal character set, which is Unicode. Usually that's the modern way to do things, except if you're using Visual Studio. Because remember, I showed you that Visual Studio will either use the locale or UTF-8. So if I put this text in a Unicode file, and let's assume that Visual Studio understood what I meant here when I wrote Greek and Japanese and Russian. It doesn't know how to write it out, because the execution character set is different. It's just going to throw me an error saying, I don't know how to encode this. Sorry, rewrite your text. So how do I solve this? Any suggestions on how to write these messages? Sorry? Escaping. Yes, thank you. The solution is to escape. So you can use the regular escape sequences. You can just use octal or hexadecimal. I hope the people in the back can see it. Or you can use the new C++11. I just used here the Q types and showed all three of them here for a specific reason. Of course, you can just write in Latin 1, and that's 1 byte per extended character. Or you can use entirely UTF-8 and write anything, and you're showing how to use it. Or you can use Unicode literals. The Unicode literals here. Technically, you can use the hexadecimal and octal forms in literal, and you can use this guy also in the non-Unicode. But you run the same problems we had before. We don't know what the compiler is going to do to output those. Here we do know. So the top one shows I have a specific character I want in Unicode, and I wanted output in UTF-16. And that's what QStringLiteral takes. Great. I finally solved the problem. Well, kinda. It's ugly. And it doesn't work on Visual Studio. Not yet, at least, because Microsoft hasn't implemented this particular guy yet, the Unicode strings. I don't remember 2014 has it. Do you remember, Olivier? They will eventually, so this will work. Questions so far? Okay, so let's talk about what Qt does, what Qt has. So let's recall that my animation failed. Let's recall the Qt types. It wasn't supposed to animate here. I just copied the slide and forgot to remove the animation. So these are the Qt types, and the question I had for you guys was which one to use when. Let's look into what they are, right? Let's look into the types. The classes in detail, and this is valid for Qt 5, the numbers. Q byte array has an overhead, and QString as well. They allocate memory. And it's quite a lot. So if you have a string of 1 or 2 characters, you've got a huge overhead. Olivier was telling me yesterday they had done some profiling, and he created a histogram of how many of the length of the strings. And he found out that, correct me if I'm wrong, 85% of all strings used in application are less than 9 characters, less than 8. Yeah, less than 16, yes. 85% of all strings are less than 16 characters, which means that you've got an overhead which is 100% or 50%. Worse than that, 50% of the strings had 1 or 2 characters. Right? So this is something that we'll have to verify and fix for Qt 6. We'll have to add the small string optimization. It's not acceptable these days, but we'll have to fix in the future, that you allocate 28 bytes to store 2 bytes plus the overhead for malloc. We'll have to fix it sometime in the future. But suffice about the overhead. Of course, qbyte array is 8-bit clean, and QString isn't. The interesting thing is that Latin 1 string and string ref, they don't own the data, so you can't store them for the future. I'm going to present you now with something about encoding. So the rules that I want you to remember. Remember always your encoding. Anything wrong here? Does anybody see the error? Yes, thank you. Here, we have an implicit conversion. So always remember your encoding, because the QString constructor and the QString const_char operator, they return UTF-8. They expect UTF-8. If your data is UTF-8, you're fine. Right? If your file is UTF-8. My recommendation, if you're just going to be clean of this, use these two macros or the couple of other ones that just give you a warning instead of giving an error. And you will know whenever you do the conversion non-explicitly. So if you look at the Qt source code, we always compile with these two macros. So the Qt source code always tells whenever it's converting to a QString to see if it's Latin 1, UTF-8, or things like that. Qbyte array, like I said, is 8-bit clean. And I'm just showing here the function that we talked about before, the read line, which returns a byte array. So examples of 8-bit data. Where would you use Qbyte array? In which conditions? When, like I showed, reading from a file. Reading from the network. Sending to the network. When interacting with, especially the POSIX-C API that takes 8-bit. And actually, we had a discussion yesterday. We were talking about Qbyte array and QString, and I don't remember who it was, but it was telling me that they converted a large chunk of creator source code to use Qbyte array instead of QString. It was, of course, not user visible. It was not something that that you guys had to deal with. But the fact is that the memory gets halved, because now we store only 1 byte per Unicode character usually. And Qbyte array is pretty good. It has almost all of the same functions that you do see in QString. The biggest difference, of course, being that they operate on 1 byte per time, and they don't fully follow Unicode. So uppercasing, lowercasing is not guaranteed to work. If you have Latin 1 strings, it contains ISO 88591 content. Be careful, because Windows has a very, very similar encoding, which differs in 32 bytes. Usually, it's not a problem unless you write the euro symbol on Windows. Same thing with the Latin 9 encoding there. And the rule I want to tell you about is use Latin 1 string whenever the function you're calling has a Latin 1 string overload, which is the case here. So starts with and ends with. They take QString and also Latin 1 string. Whenever you see Latin 1 string, whenever the function you're calling has a Latin 1 string, that's the one you want. These functions are optimized to work without conversion. So if you ask, does my string contain UTF-16 data? Of course. Start with this Latin 1 string. Qt will not convert to Latin from one to the other and try to do the matching. It will actually compare 1 byte to 2 bytes, 1 byte to 2 bytes, and see if it works. The other class that we all looked at is QStringLiteral, which is not a class, of course. QStringLiteral is read-only shareable data. It means that whenever you use it, this does not get a memory allocation. There's no own, it doesn't own the data, it's simply there. It exists. is static program memory. And however many you have of those, they're shared with other processes running which have the same strings. If you've ever tried to look up the source code of QStringLiteral, it's this actual macro here, which is a little of a mess. It simply is trying to create, this is the same as the private inside QString. And this data header initializer is the 24 bytes overhead, because it contains size, contains the reference count, and a pointer inside. The good thing is, like I said, this is static const. This is shareable. This will not allocate memory. What I'm working on already, I actually made this work for Qt 5 before we did 5.0, but we didn't have time to finish it. I started on a new version of it for Qt 6 now, which has a smaller overhead. Because now it only has one chunk of data. Everything else is shared. The big difference is that QString increases in size, but that's something we can do also for the small string optimization when we can do it. So finally, we have the standard library types. I'm not going to get into that. I'm just showing that we have a couple of functions in QString to deal with them. We don't have any to deal with the new standard library types because, we don't like standard library. Actually, it was just happened that nobody asked for it. We never thought of it. Never wrote anything about it. So as you can see, we do have a few functions that we added to take car16 and car32, but nobody asked for more. So we ended up not writing. When we're discussing here and realized we're missing the constructor. We're missing something that takes the data and returns as a new car16 pointer. I guess we're going to add it soon, but we haven't. So let's do a little exercise. Which of these alternatives is best, given the functions above? Is it that starts with string, with directly literal, the Latin one string, or the string literal? All of them work. All of them produce the same result. Which one is more efficient? Yes, thank you. So the answer is the one with Latin one string, because starts with has a Latin one string overload. This means that I do not allocate memory to create the Latin one string, and I don't create the extra, and the function always does operate directly on it. Another exercise, which one of these alternatives is best? I'm just returning a QString. David? The last one, QStringLiteral. Because no conversion happens and because no memory allocation happens as well. So remember what I said. QStringLiteral is read-only memory. It does not allocate memory to return that string. So this is simply an assignment of a few values inside the QString class and returning it. There's no memory allocation. This runs in constant time. The other two have to allocate memory. They're actually more or less the same. This one is actually worse because it tries to do UTF-8. I've created a lot of optimizations for the UTF-8 decoder. Olivier has a few more up his sleeve. But it's pretty good. This one is the Latin one string is slightly better. The string literal is better yet. Now, which of these is best? Now I'm not just returning, I'm concatenating with something. By the way, you probably never do concatenation of dates like this. But which one of these is better now? It's not the first one. Actually, the answer here is it depends. Usually, these two will have more or less the same performance impact. This one will probably occupy more memory in your program. Here's why. We have the such thing as called the fast operator plus, which is the QString builder. You might also know it by this other name. If you define this extra macro here, then the left side is actually more efficient than the right side. Otherwise, it's worse. Let me explain why. The fast operator, usually if you don't define anything, what it does is that the C++, the compiler needs to call an operator plus here of these two arguments, the first two, which returns a temporary. Then it calls the again operator plus with the result of the first plus the second one. So 2 temporaries, 3 temporaries, 4 temporaries, 5 temporaries, 6 temporaries. Which means that the compiler actually, at runtime, you allocated memory for 6 of them before the result got finished. So if you don't have anything special, and if you're using, for example, std string, the right side is more efficient because the temporary gets destroyed at the end of the line. Actually, there's no temporary, it just appends to the same one. It continues occupying more memory. It just reallocates it. Now, thanks to Andre, a couple of years ago, we have the fast operator plus, which is a chain of templates, so a bit of black magic. I'm not going to get into how it works. What it does is that it does a first pass over everything, calculates the size, allocates once, and then just copies the data. So that means that if the fast operator plus is active, the second and third options in these slides actually just run the more or less the same code, with the difference that the second one, the middle one, does not allocate memory. So to summarize, here are the rules that you have to remember. First of all, always know your encoding. If you're dealing with qbyte array, if you're dealing with 8 bits, make sure you know where your encoding is. You might ask, hey, how do I detect what the encoding is if I don't know for sure? Detecting the encode is like predicting the weather. You might get right 90% of the time, but it's the one time you get it wrong that's going to bite you. Detecting the encode is not a good idea. Make sure you remember it. Make sure you know it. If you're transmitting data over the network, make sure that the protocol you're using is well-defined which encoding it is using, usually UTF-8. Once you know the encoding, you know the right type. If you're dealing with 8-bit data, it's qbyte array. For storage, of course, you use QString. QStringRef is for you if you don't own the data. You just want to return a view into that. Otherwise, you use QLatin1 string if the function takes a QLatin1 string. QStringLiteral if you're not just about to reallocate data, which was the case in the last example. If you're about to reallocate data, QStringLiteral is not a very good idea. Not because it's inefficient by itself. It's just that you wasted memory because you're going to reallocate anyway. You're going to occupy memory. You're going to do memory allocation anyway. Might as well just do it once and for all. Questions now? I'll start here.
When you showed the AP examples with starts with, etc., then you passed the QLatin1 string by value, not by reference, as the other parameters.
Good question. Is this working? Can you guys hear me in the back? Yeah. Okay. So you were saying that I showed you, where was it? This, and I passed QLatin1 string by value, not by constref. That is correct. And this is what Qt5 does. I've got a blog on this. It's a little complex to explain. It's more efficient to pass something that is less than 16 bytes and is trivially copyable by value instead of by reference. There's a couple of rules. I could get into this at a different time over beer if you want to. Trust me, in this case, it's more efficient. I can show you my blog afterwards where I talk about it.
When you say that if the function takes a Latin1 string, you should use QLatin1 string, is this only for the case where you have a literal to start from? Or would that be the case also if you had a qbyte array to start from?
Sorry, I did not understand the question, David.
You said if there is an overload with a QLatin1 string, use that if you can. Is that only for the case where this is a literal, like in this code here? Or what if you had a qbyte array with some data that you got from the network? Would you then say QLatin1 string of my byte array or not?
So the question is, imagine I'm going to call, starts with, there's an overload with QLatin1 string, and I have the data in a byte array. If your data is Latin1 string, yes, do it. You can do this. Otherwise, what is going to happen if you don't do this, if you don't use QLatin1 string, you have to convert to QString some other way. And it's going to call the first overload. The difference is the memory allocation, right? Starts with and ends with, and most of the functions, they actually operate faster if both data sets are QString. Comparing Latin1 to UTF-16 is kind of efficient, but not as efficient. However, the cost of malloc is much higher. Like I said, most strings are short. And the cost of malloc is just an order or two of magnitude higher. So creating the QString in order to call it, you lost it. Other questions? I don't know if you can get the microphone, just speak up.
I was just wondering whether it is possible to use UTF-8 natively in QString.
Okay, so the question is, can I change QString to store UTF-8 instead of UTF-16? We've debated this question quite a lot. A lot of people make the argument that UTF-16 is a waste of space, especially in this room and the United States when we go for dev days. Most of us are writing in English or writing in one of the Western languages, in which case UTF-16 is a waste. It just occupies almost double the amount of space that it would on UTF-8. It's not the case when you go to Asia. Right? UTF-16 actually is shorter, more space efficient for Chinese, Japanese, and Korean. Another reason is that when calling the ICU API, it's all UTF-16. When calling the Windows API, it's all UTF-16, so we'd have to convert anyway. The biggest problem for us in order to make what you're asking for possible is the amount of source code that exists that just assumes that it is UTF-16. Because you've got the function that is the dot data or dot const data in QString, and it returns to you a pointer to UTF-16 data. So it's very difficult to store it in something different. What I've been researching is to cache the old result or to keep it until you ask for it. So for example, a lot of uses of QString is put data in, so take from UTF-8, put in QString, and then convert it back to UTF-8, right? Never needing the UTF-16. Can't we just cache it and avoid memory allocations? So this is something that I've been wanting to look into and research. It gets tricky with threading because QString is supposed to be thread safe. It's supposed to be reentrant, and there's an extra guarantee that if you're just calling const methods on a shared QString, then it still operates the same way. That breaks with threading. So research for the future. We'll see what we can do. Other questions? the back, and then.
Can any of your examples be improved with move semantics? I'm thinking about the plus example, for example.
So the question being, can these be with move semantics? This one is in particular. Could this be more efficient with move semantics? Actually, this one. I said that if you're using standard string, the first one is a lot worse than the second one because they don't have the operator plus. Now, with move semantics with C++11, it means that the temporary can actually be overwritten because I know it's a temporary. So yes, move semantics here would help. We haven't implemented operator plus with move semantics for QString. Mostly because we have the fast operator plus. We haven't felt the need. We have added move semantics to many of our classes and to try and improve functionality. Let me give you an example. Starting in Qt 5.4, starting Qt 5, I have Qt Creator running. Qt Creator running. Too big. Oh, the other way around. Yeah, there you go. So we have started to use move semantics. And here's an interesting one. So if you call to Latin 1, how many of you, by the way, recognize this thing here after the function? Raise of hands. 10 people. So this is the ref qualifier of a member function. It means that the second function is called whenever the QString is a temporary, where it's an R value. The first one gets called when it's an L value. So the first one is the one that you've been calling all the time. It just creates a new byte array and returns it. The second one is the helper in place. So it will do, if I'm not shared, if I'm ref count is 1, I'll just reuse the memory. Remember, Latin 1 is always half the size of UTF-8. I don't need to allocate memory again. I just reuse the memory. Something for the future is also to do the UTF-8 helper in place. I think this is something I haven't published yet. Not sure. This might be just my local version. But we've started to do move semantics.
Can you say a couple words about string lengths? Because, okay, for QString with the 16 bits, it's when I ask for the length, it's always the number of printable characters, isn't it? Okay, for QByte arrays, it's the number of bytes stored in the array. And level string?
So here's an interesting question. You've got a very good question. The difference between number of bytes or number of UTF-16 words, length of the string, and width of the string. So both QByte array and QString return the number of items in the array. So in QByte array, it is the number of bytes. In QString is the number of UTF-16 words, which means that if you have surrogates inside the QString, they count as 2. Now, the question is, what's the width of a string? Because Unicode has characters that are regular width, double width, and 0 width. So just by looking at it, you don't know what the width is. You have to actually look up the properties to know, is this a combining character or is this double the width, so I can know if it fits on my screen. If you want to know the width, it is QFont metrics. You can just ask with, we don't have anything for regular non-font, but because usually we don't do text UIs. So everything you're going to do is font metrics. Other questions?
I think your question was more about QLatin1 string and QStringLiteral, right? You wanted to know the length in these, like.
No, it was
Okay.
my question was because sometimes the characters in Unicode are represented as 2 bytes, as 4 bytes. Even in UTF-16, you can have a single printed character represented as 2 code points.
Oh yeah.
Yep, it can happen. 1 character, multiple code points. But one more and then we're out of time.
Okay, any hints regarding QML and conversion between C++ to QML regarding strings? Can we use Latin1 in QML, for example?
So I did not understand the question.
So in QML, we have only 1 string
Yes.
type.
Yes.
So any performance tips for this one, or do you plan to improve?
So the difference is that in QML, since it's a superset of JavaScript, it uses the JavaScript interpretation of what a string is. It's not QString. It's actually a JavaScript string class, which fortunately, because it was based on Java, has some of the functions that we know in Qt, like starts with and ends with. But it's not QString. It's an internal representation of the JavaScript engine. The question you might want to ask is, how does that get, which one is best when calling into C++? Both of them require memory allocation. There's no way, because the JavaScript engine inside QML has its own representation. I think it caches QStrings. So if I'm not mistaken, and I'm not the JavaScript expert, the QML expert either, QStrings would be more efficient because it can cache them. The internal representation knows if it has a QString and it will cache them. Something we wanted to do again for Qt 5 and never had the time was for a QString to know that it doesn't own the data. And when it gets to the last ref count, it just calls a function, say, I'm done with it. Now you free it. It would help with WebKit, Blink, and this kind of engines that also do strings, UTF-16 strings. We never got around to it, and use case is very limited. So, no, wrong screen. Oh, I exited my presentation. So thanks for coming, everybody. Thank you.